Welcome to Redshift, Team 4048's Fleetbot challenge called Level 3. Now, we named it Level 3 because the Society of Automotive Engineers defined Level 3 automation as a vehicle capable of driving itself under ideal conditions but with limitations. And the goal of this challenge is to have an automated vehicle go around this course that we designed and go from start to finish with some optional components. And our optional components include turning on the headlights inside a tunnel, stopping at a crosswalk to let pedestrians through, and navigating everything else and coming back to the start-finish line. The rules are set up so that they kind of, in some ways, mimic an FRC competition in terms of having robot rules, electrical rules, and we had a kit of parts. So of course this year was with the pandemic year, we didn't have a chance to have a real FRC competition, and we created this challenge as a replacement so that instead of having team-to-team competitions, we have individual-to-individual competitions. Students were allowed to collaborate with each other. They were allowed to share code, share ideas, share design approaches, and so on. We ran some online classes to help new students get indoctrinated into programming Arduinos. They were given the basic kit of parts, but they were also allowed to ask for additional parts. So again, just like in FRC, where you can embellish your robot beyond just the kit of parts. The kit of parts is never enough to do everything.
So the kit of parts includes these pieces that go one on top of the other for the chassis. There's 4 motors here, and the hardware to mount them onto the chassis, and then the 4 wheels. Then there's power connectors for the 2 different kinds of batteries. The Arduino microcontroller that controls the whole thing, and students spend most of their time programming that thing. And then this is the motor shield, which is the thing that drives those motors. And then some wires and some zip ties, a switch for starting the thing. And then we include in the kit 2 little sensors for sensing the black lines on the track. They can get more if they need them. And then you can wire the whole thing up with this little prototyping board. And that's about it.
When we first started talking about this competition, we came up with a list of elements that we'd like to see included in the track challenge. That is both gentle turns, sharp turns, ramps uphill, ramps downhill, the dark area where the headlights would have to come on. And so we sat down and started mapping out how to lay out a track. And the first thing we had to look at was how big the robot cars were, which sort of would define how big the track would have to be. It needed to be long enough to take a reasonable amount of time to do. We don't want something over in 15 seconds. We came up with about a 8 by 12 field size. It's made of 3 4 by 8 pieces of 1-inch architectural insulation foam. We made the track surface for the flat part of the track out of just poster board. So using, again, the CAD dimensions, transferred that onto a poster board and cut out the straight sections, some of the curved sections, and then laid the black electrical tape that we used to make the marking lines on top of that. Then each piece would be fit onto the baseboards so that they could be assembled, transported and assembled here. The ramps were made from foam core poster board, which we've used for other things before, to have a more rigidity to them than the just poster board itself, and took pieces of the same type material as the base plates are made out of and cut wedges to glue to the underside of the foam core board to make a well-supported ramp, and then also similar pieces to build the curved piece at the top of the ramp. For the dark spot, we made a tunnel out of HVAC flex ducting. We originally had a different configuration for the figure 8. There were a number of spots that the robot simply couldn't navigate successfully. So we reconfigured it so that all of the intersections are approached from a perpendicular direction. So you're not coming into the intersection from an angle. You do have to navigate the turns to get your car or your robot around to the point where it will come to an intersection, but there's no turns leading directly to an intersection. And the last part was the banked straightaway. That was one of the things that we wanted to have included. And again, that was just taking the foam board and making wedges out of the baseboard type foam to prop it up. Then once it was assembled, we used white gaffer's tape to join the pieces where the segments of the track intersect, and also to attach the top and bottoms of the ramps.
The FMS is something that, well, when you go to real competition for first, you have this huge elaborate setup with lights and whatnot. We figured we needed to have a software, or we needed to have something that checks the time, and that is built using light sensors here on 5 different points where we can check the time. So this line is crossed twice. The individual checkpoints here on one side is the sender and the receiver, on the other side is the sender and the receiver, and each one has an LED to indicate what status they're in. They're built using a foam board, cut in piece, that it's shallow, that you can run over it to the robot without damaging anything. Inside is one of those programmable LEDs, so I just use one in each location and program them, and then long wires run under the board to connect them all to an Arduino, which is running all that, which is sitting here on the corner, so this is where all the wires get combined. And what the Arduino is doing, it checks when the robot passes the sensor, like that. Here for this one, it changes from blue and red blinking to green and red blinking, because this sensor will also be used a second time at the end of the race. And then for each other, as soon as the robot crosses the line, it turns green to indicate that it's checked off. Each of those events is reported on the serial monitor, and this is read by the laptop here with a Perl script that just reads in all these values, extracts the time, and creates a log.
Here is a brief overview of the rules. There are 5 checkpoints, the 5th being the finish line. The vehicle that has completed the most number of checkpoints in the shortest amount of time wins. Vehicles must start and stop in standby mode. This is indicated by a steady yellow LED. Vehicles exit standby mode through the push of a button, and once they are in a run mode, they must flash a green LED between 1 and 5 times per second. Vehicles can earn bonus points by turning on headlights inside the tunnel and stopping for between 3 and 4 seconds at a crosswalk. If they stop at a crosswalk, they must flash a red LED 1 time per second. Vehicles can also get bonus points for stopping automatically when they cross the finish line. Here's the scoring summary. Penalties are applied before bonuses. Penalties add time to your final score, and bonuses deduct time. All right, this is Timothy, and the robot is, I hope this works, no?
I think it works.
I think it works, and this is our first run. Go for it. Oh wait, did he start this thing?
Yeah,
Oh. would be quite upsetting.
If it's a practice run, it doesn't matter.
Oh, but it's It's
not.
a real one.
I don't have any practice runs because I also have to do the interview.
He's got 2 checkpoints.
Wait, isn't it two? Isn't the third one over there? I don't know where
He's
it's
got
going.
headlights.
The lights on. And the save machine works. Hurrah.
And he's got his 3 seconds at the crosswalk.
Oh no.
Oh,
Ah.
well, he stopped, technically, that's, we don't specify where you stop, just that you stop.
Aren't you not allowed to flash the LED in any other part of the course?
Right, but you technically stopped at the crosswalk, it's just a little bit into the intersection. Not very pedestrian friendly, but you know, you tried. Didn't run anybody over, right?
But there's no one to run over.
Ah, there you go. Problem solved.
Yeah, I mean.
Now we'll see, coming out of the home stretch here.
No, no. Oh no. That is the upsetting part. It was so close, yet so far.
Okay.
Okay.
I saw the headlights flash briefly.
Oh. Maybe hang on coming out.
And we're gonna stop at the crosswalk for 2 seconds. Another 3 seconds at this crosswalk. And the home stretch. stop. Ooh, unlucky. Alright, there's my first run.
So, yeah.
Wait, whoa, hold on.
Oh, wait.
We're not ready yet. Well, okay, go ahead, that doesn't matter. Just
Okay.
run.
Should I have waited?
No, just go ahead, keep going. Successful crosswalk. Second successful crosswalk.
Oh my god, okay.
Still good, you're still good.
Should I like, is it,
As long as it makes it around, you're fine.
Look at that. Yep.
Oh!
oh my god.
Oh, so close. Kevin's first official race. So his robot T800. That was up.
Wow.
Messing with you.
Yes.
Okay, did that register as a?
It hasn't registered yet.
Oh,
It's stopping now?
is it done? It's in standby.
I think we should count that as finished, right?
We need to make it go a little farther.
Really? No, that's a good one time of never.
I like the sound effects the wires stretching on the phone board.
Okay.
Watch your mess up on this one, I think it'll be really funny. Did somebody bend the track? That bump wasn't there before.
Today, with the doors open and humidity coming in, it's like the cardboard is expanding a little bit. So it's buckling, so it's held down in places and not held down in other
Did it
places.
rain? Frosties.
Yeah, the whole track sign mimic our crumbling infrastructure.
Probably walk with it, so it doesn't like a problem. Go baby. Okay, stop.
Whatever, nice.
A little late.
Yeah, it's a single light thing that's buried back in there, it's hidden behind it. Under the wire.
Oh, sweet Jesus, okay.
Oh, actually, well,
It's up in the middle of the road.
But it did stop.
it did stop.
You know what?
Pedestrians maybe not be too happy about crossing, but
It's okay.
It did
I mean,
stop
my
with
line
the-
count's gonna be off for the rest of the summer.
It stopped with the pedestrian underneath it.
Pedestrians can, they can wait a little, take a little detour.
so just so you know, as long as if you stop if you cross the start finish line,
It's
That's-
probably not gonna stop on time.
so well, we'll see. Just don't pick it up. Okay, now hit the stop button.
Takes a try. Okay.
Still good?
Yeah, sure.
Go, just see what happens.